Welcome all, and this is a quick problem from even and odd function, relevant and frequently coming in G examination. So let's try this question. Which of the following functions are even? So we need to check for even and odd. Now, just quick recapitulate. A function is even if f of x equal to f of minus x for all x belonging to the domain of the function. And the function is odd if f of minus x equals minus f of x for all x belonging to the domain. Of course, for being odd, the function must have symmetric domain. So geometrically, it represents for an even function, you'll have the symmetricity about y-axis because whatever we are getting on x as the output, the same output we must have on minus x. Similarly, for the odd function, we must have symmetricity about origin. The reason being, since it's true for all x in the domain, let's say x equal to 0, if I'm taking in the domain, considering symmetric domain from minus L to L, then definitely f of 0 is gonna be minus f of 0, and which forces f of 0 to be 0. Okay. Now, the moment you look at the question, the first field that will come is integration. So we'll try to integrate. So of course that's not required because you can't expect the problem setter to give you all these four integrations just in a single problem, right? So what we do, we'll use a theorem which is known as Leibniz rule. So if I'll differentiate the first option f dash x, that's the usual trick whenever you have variable limit of integration. So we'll get ln of x plus root over 1 plus x square times derivative of x, which is 1. So this is by Leibniz rule. Now I can check this function is even or odd. So if I replace x with minus x, it's ln of minus x plus root over 1 plus x square, and clearly all this should be in the domain. So what if I'll add f dash x plus f dash minus x? Now why this motivation of addition comes into picture? Because let's say if psi x is a function, and if I get psi x plus psi of minus x at 0, it's equivalent to telling psi of minus x as minus psi of x, which forces psi to be an odd function. So that's my agenda. I'm taking f dash x as some function psi of x. So according to that convention, f dash minus x is going to be psi of minus x into, using log property, minus x plus root over 1 plus x square. And that gives ln of mod of 1 plus x square. You can treat this as b plus a and b minus a minus x square. And very nicely it turns out to be log 1, which gets 0. So I can tell f dash x is an odd function. Now from here I can conclude like f dash x is an odd function. So from here, can we comment anything about the behavior of f? Let's see, can we comment that f of x is an even one? So here we go. Let's try to do it. So f psi of x is an odd function, and I'm interested to integrate from, let's say, 0 to t, which will give f of t. So I'm proving that f of t has to be an even function. So replace t with minus t. I'll have 0 to minus t psi of x dx. And now I'm going to use change of variables. So if I'll make x as some minus y, so that will give me 0 to t psi of minus y dy minus of that, and this quantity since psi is odd, so minus will be out, so I'll get 0 to t psi of y dy, and that is precisely same as 0 to t psi of x dx. So by this logic, what I have proven, if f dash x is odd function, is integration by fundamental theorem of calculus 0 to x f dash x dx, which is f of x, is an even function. So यहाँ से what I got, the first answer holds true. Similarly, you can check for the second option. G of x is also an even function, so that's easier to check now because I can write g dash x is going to be 2 ka power x plus 1 divided by 2 ka power x minus 1 times x by Leibniz rule. And if I find g dash minus x, that is 2 raised to power minus x plus 1 divided by 2 ka power x minus 1, that is x times minus x, right? And this you can evaluate as minus x plus x into picture which simply gives 0. So by this argument, I have shown again g dash minus x plus g dash x equals 0. Hence, g is an odd function. By the previous proof, this integration must be even. So option B still holds true. Now I'm leaving up to you. Exactly in the same fashion you can show h dash x will be odd. Hence, hx must be even. Similarly, L of x is an odd function. Hence, is integration of even function. Note the converse of this statement is not true. In the sense, like what if a function is an even function, then can you tell its integration from 0 to x will be odd? Think about this, and you can prove exactly in the same fashion. Now, one of the trick behind this even and odd behavior is you can always check for a function the value at x equal to 0, because if the value at t equal to 0 or x equal to 0 is 0, then that certifies like there is chance that the function will be an odd function. If it is non-zero, then it's guaranteed like the function can't be odd, because for any odd function, if 0 is in the domain, f0 has to be 0. There is no other way out. So that gives in. For instance, let's say if I'll differentiate, I'll get this function as a function of x clearly. If I'll put x equal to 0, I'll get root 1 minus root 1 0. So that gives at least a hint like there is possibility of function being odd. Similarly, you put t0, you'll get ln 1. So chances of being odd. Put t equal to 0 here, because after differentiation we get in terms of x, right? So if I'll put x 0, clearly it's 0. Similarly at x0 or t0, whatever you tell, this function dies. So there was chance of these functions to be 0. So that's necessary condition but not sufficient, of course, just like dimensional analysis of your physics. ठीक है. सो आई होप एक सिंगल क्वेश्चन से आप काफ़ी मल्टीपल आइडियाज आपको समझ में आया, और यहाँ पे बेसिक आइडियाज जो था वो फंक्शंस का था और लिबनीज रूल को कैसे अप्लाई करते हैं इन अंडरस्टैंडिंग दिस. थैंक यू, हैव अ गुड डे. प्लीज डू लाइक एंड सब्सक्राइब द चैनल if it is relevant for your studies.